All right, it says where T is time in minutes and R is measured in feet. Okay, so that's important. It says, what is the area of the oil slick in terms of T, and how large is the area after 30 minutes? Okay, so they want to know what area is, and we haven't talked anything about area in the problem, right? Okay, they haven't identified that, but they told us that we were spreading outward in a shape that is roughly circular, right? So what formula does that provide you for area? Pi r squared, okay? So area is equal to pi r squared, okay? So that is one form, that is one function, okay? And that is, if you think about that, maybe this is a better way of writing it, area, the only number that affects area is the radius, correct? Okay, so area is better maybe written as a function of the radius. Okay, it's dependent on the radius. Okay, well, what did we just say R was? Square root of 2t, right? Okay, so now I'm actually asking what is, if R is the square root of 2t, okay, what we just asked here, come on. Okay, essentially is to take A, if we look at what this means, that's A of R of T, isn't it? Okay, which if we think backwards, maybe you were right this way. A composite R of T. Okay, so now, writing this out, okay, if I've got area, and now this is my inner function, and that's going to represent what I plug in up here, okay? So instead of R, I'm going to plug in square root of 2t. Okay. Doable? Okay. Cancel. 2 pi t. Correct? Is that right? Okay, so you got square. Hold on a second. Maybe I missed that. Yeah. So you got the t's underneath the radical, right? Yeah. Does that make sense, everybody? So now, area is defined off of time instead of radius. Does that make sense? So now, somebody doesn't have to go from the oil spill to the edge of the, from the tanker to the edge of the spill, measuring that radius to find out how big that oil slick is. They can simply say, okay, how much time has elapsed, and then we can gauge the size of that circle. Does that kind of make sense? Okay, so after 30 minutes, all I got to do is plug in 30 there, and I've got my answer, right? Okay, I'll let you guys do that on your own. But what is, and now obviously that's going to change, right? Because we've got some physics going on. Say I got this oil spill, this oil tanker. You guys know what an oil tanker looks like, right? Okay. Full of oil, it starts to spill. So it runs into, let's say it runs into like a reef or something, and it starts spilling out. Well, initially, more oil is going to come out than what happens maybe hours later, right? Because the pressure of the oil that's in the tanker, okay? So think about this. If I've got, let's just use a cup. Okay, I got a cup full of water, and I put a hole right there. Is there going to be a lot of water come out? In comparison to when the water is down there, okay? When the water is down where the red is, there's not a lot of pressure to press out the remaining water, right? So it's going to be a slower rate of decrease, okay, in regards to how much water or oil is inside that container. So we use calculus, eventually with what we call rates of change, to analyze that maybe a little bit better. Okay, so this problem gets a little bit more complex once we learn a little bit more math, and we can apply it a little bit better. Okay, which would tell us then, as time is going on, that initially that circle is getting really big, okay, really fast, right? But as time goes on and there's less oil in that tanker, the radius of that circle and then its respective area is it's slowing down. Does that make sense? Okay. So those are the kind of things to think about and why we're doing these composition of functions. I saw one. Oh man, we're running out of time. Let's do. Tell you what, I'll put one in a video that I want you guys to look at because it's important in regards to the fact that, and I do this when I get results that are, maybe I get a domain restriction that x cannot be -3, but then I get a domain restriction that x has to be less than or equal to 5. If you get domain restrictions that look like that you have 2 points and one of them is an inequality or both of them are inequalities, not only is it a good idea, obviously go through and find out where they overlap and that kind of stuff, but it's a good idea when you're done to look at your number line and choose values out of the intervals that creates. Okay, so this is going to create like -3, 5, right? We're thinking that stuff, but we've got an issue here at -3. What I would do is I would check a point here, check a point there, check a point there. Because sometimes what we might think is that x is going to be less than or equal to 5, but not being equal to -3, sometimes these values don't work. And these will be the only ones that do work. So it's a good idea to check. And I'll explain that in a video, but we're running out of time here to do the full problem. Tomorrow, we are going to start talking about inverse functions, which we're not going away from composite functions because inverse functions are a particular, a special case for composite functions. All right, it's basically,